Recording. So, lesson 37, the first thing we're going to talk about is line as a locus. Now, what this means, and I'll get to it in a second, but basically multiple, okay? So, line as a locus, there are some pre-information that we need to know that we learned in the lessons before, and that would be the distance formula. And what is the distance formula? No, that's different. X2 minus X1 squared plus
Y2 minus Y1 squared.
And here's the thing. Could I switch the Y and the X parts completely around? Yes. Could I switch X1, Y1? Yes, as long as I switched. Here's a trick question. That was kind of a trick question, the fact that it actually doesn't matter. If I switch the X1 and Y1, or X1 and X2, I could leave the Y's the same. So, let's try this once. If I asked you for the distance between these 2 points. This is stuff that you had to do in your homework up to now, was find the distance. They gave you a point, and then they gave you an XY point. So they kind of left that point out. There are 3 to 4 different versions of this that you guys could set up. And they're all equal. Okay, so the first one would be this square root of. I usually like to keep my variables first. So if I would have started with the second point here as point 2 and this one's point 1, well then I'd have something like x minus 4 squared plus y minus 2 squared. Would you guys agree with that? But we also said that I can just switch those points around, and we hopefully should be able to say that it would be 4 minus x squared plus 2 minus y squared. It's the same thing, yes? Okay. But what I'm trying to also say is because we're squaring them, any negatives will become positive. Therefore, I could switch this around. I could put x minus 4 here plus 2 minus y. I could take one piece from each part. And obviously the other one would be take the second x version and the first y version. And I could have a fourth one. They all happen to be the same. Now, if I was given a choice, I would choose the first one because I always like to put my variable first. It's generally how I usually see something like x minus 4 squared versus 4 minus x squared. In my mind, it's something I'm used to, so it's easier. And probably in your case as well. Okay, so all of those don't matter. So here's the thing. We need a definition of a line. Definition of a line. It says that a line is the locus of all points that are equal distance from 2 specific points. Equal distant.
What do you take for sleeping aid?
So a line is the locus of all points that are equidistant from 2 specific points. So what does that mean? It means something like this. If I had a point A and I had a point B. Those are my specific points. What it means is that if I had to draw a line that was equal distant from all of those places, the line would have to be kind of like right down the middle, yes?
Yeah.
And what it means is that if I choose any point, x comma y, the distance, we'll call that dA and dB, well then dA has to equal dB. The distances from each of your specific points to any point on that line will be the same. Whether it's here, 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 it doesn't matter. Then it forms a line. It's all distances that are equal from those 2 points. So what are we going to do? We are actually going to be taking the 2 points we're given and arbitrarily setting them equal, or finding the distance between 2 points. You're going to find the distance of dA and find the distance of dB. And then at the end, you say, hey, those should be the same. And then you can solve for the equation. So, what is your first problem? Your first problem will be, find the line equidistant from the points 4, 2, and -2, -3. When you see those words saying equal distance, that means you use a locus definition. There are more than one way to find the line between these 2 points. There's equal distance between these 2 points. Notice it doesn't say going through those 2 points. So if you try testing the line equation that you guys will get from here with these points, you're going to find it doesn't work, and you'll be like, Mr. Konchak, I think I did something wrong. I'd be like, no, you're not. The line doesn't go through those points. So the first thing you need to do is, again, set up the distance between those 2 points and an arbitrary point. And this arbitrary point is what I'm going to call x, y. It's like my third point. So set up the distance between these 2 first. 4, 2, and x, y. And again, I always like to use my variables as point 2, because then it leads off the way. So, I'm going to change to a little bit darker font here. Let's go with purple. Square root of x minus 4 squared plus y minus 2 squared. That will equal, going the other way, the square root of x. Ooh, is it plus 2 or minus 2? It's minus a negative, which is plus 2 squared, plus y plus 3. Again, you're subtracting negative squared. And now, we just solve it for y. It wants your answer in slope-intercept form. That does not look like slope-intercept form. So let's put it there. What we need to do is be like, hey, wait a minute. I'm square rooting both sides. What can I do then?
Cancel.
Cancel them by doing what to both sides? Squaring both sides. And if you square them, the squares and the square roots will cancel. I can ignore, basically, the square roots. Now I just have to focus on the stuff that's on the inside. Each one of those groups are squared. So, what is x minus 4 squared? This is where I am not going to sit there and write them next to each other and FOIL them out 4 times. Because I got 4 different groups. I'm hoping that you guys remember the formula that you guys are supposed to know. That if it's x, if it's, we'll say, a minus b squared, that it's a squared minus 2ab plus b squared. And if this is plus, then that becomes a plus. You guys should remember that. Perfect square binomials. Okay? Just like the difference of squares. They come up enough that you guys are starting to memorize that. And now I'm going to take that all away. You better have wrote it down. Okay. Now, what does x minus 4 squared become? It should become x squared minus
2. Oh, wait.
minus 8x, because x times 4 plus 16.
Be a 9.
Oh, okay, I see now.
Right there, guys. I did that. I put the pattern on there so we wouldn't have to worry about it. Next one. Plus y minus 2 squared would become y squared minus y times negative 2 times 2. So that become negative 4y plus 4 equals, going across, x squared plus x plus 4 plus squared plus 6y plus 9. Okay, does everybody get where I got all those from? This goes a lot quicker than having to FOIL them. First outside, inside, last. You square the first term, square the last term, multiply them together, and then multiply by 2 to get the middle term. A lot of students like to forget that middle term on each one of these. What I then can do is start to simplify. Hopefully you recognize that you have an x squared and a y squared on each side. So when I subtract them away, they cancel or disappear. So let's use the red marker for that. Gone, 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 gone. Those all disappear. We're happy about that. Now, the rest of this is, we could gather like terms is what we have to do. We have to essentially get y by itself. So solve it for y. My next step would be, because I have some single numbers like 16 and 4, I'm going to put those together. Gather my thoughts just a little bit. And just make that a 20, right? Get rid of the stuff that I canceled away. Equals 4x plus 6y plus 13, is it? And now we can think a little bit more about how we're going to solve this. Are we going to bring the y's to the left or to the right? Because we're going to get those to be positive and by themselves. Or are we going to bring them to the left, or the x's one way or the other? What do we want to do?
Bring the y over to the right.
Right, okay. I like that. I like bringing the y's to the right because it stays positive. And if I did that, I'd have to add 4y. Well, if I'm moving the y's to the right, that means everything else needs to go to the left. So I'm going to subtract 13. And I'm going to subtract 4x. So when I simplify it all up, these are gone. Oops, not those. And these are gone, yes? What's negative 8 plus negative 4?
Negative 12x.
Plus
7.
equals 10y, because those are gone. And then divide everything by?
What about the 2y? Oh, no.
Because it's a positive, yep, it's a positive 4 and a positive 6. Divide everything by 10. So y is going to equal negative 6/5 because we can reduce that. Yes. 7/10. Done. You just solved for the equation of the line between 2 points. It's very nice. It's handy. It's a little intense with your squaring and gathering like terms, but it does work. So, do the same thing with these 2 points, please. 0, -4, and 5, 2. Okay, I have it set up arbitrarily, chose x, y, because we don't know the point that's going to be on the line we want, and I set it up. Now we just need to square them all. I'm going to get rid of the square root right away as well. You can just act like they're squaring both sides. They're gone. The nice thing about the first one is it's just
0.
no, it's x squared.
I meant like
Right. There's a 0 in it, right? And that makes it nice. So therefore, you get that plus y squared plus 8y plus 16 is equal to x squared minus 10x plus 25 plus y squared minus 4y plus 4.
Why is it minus? Like, why minus 2?
Because, okay, so hopefully we recognize that the x squareds will cancel, the y squareds will cancel. That makes it a little bit easier because all that's left is 8x plus 16 over here and negative 10x.
8x. 8y.
Oh, that's an 8y. Yes, sorry. 8y minus, or it's plus, well, minus 4y plus 29.
Up until the 25. Oh, you combined it.
Combined it.
Okay. Yeah, we don't have the y's on the left side.
We're definitely bringing the y's to the left. So adding 4y. I'm going to subtract 16 then. This one's going to work out quite nice because not too much sliding around. 4 plus 8 is 12y is equal to negative 10x plus 13. Divide both sides by 12. And so y is equal to negative 5, 6 again.
X plus you just like 5, 6.
So actually, both these lines that we just found between these two sets of points in these two problems are what to each other?
Parallel.
Parallel. Okay. Okay, everybody's good? Last one.
It's not like any of us do it while we're here. Just throwing it out there.
Midpoint. Midpoint formula, guys, is x1 plus x2 all over 2, comma, y1 plus y2 over 2. It's the average of the x's and it's the average of the y's because when you take the average, you add them up and divide. So therefore, I'm just averaging the distance between the 2 points divided by 2.
And can those be switched?
Those can be switched as in x2 plus x1 because you're adding. Adding is associative. So we're good.
Oh, yeah.
So if I ask you to find the midpoint between 2, 6, and 4, negative 10, can you do it?
Yeah.
I hope you can. You guys would say, oh, that's negative 2 plus 4 over 2, comma, 6 plus a negative 10 over 2, comma, parentheses I meant, not comma, and it equals, what's negative 2 plus, maybe 2 over 2 plus negative 4 over 2, which is equal to 1, comma, negative 2. Now the reason why they're teaching you this now is because there's another method for finding the line using the midpoint formula, which we will talk about at a later date.
I am so
Your homework. I will go back. 266, 1, 3, 6 through 8, 14 through 15, and 21.